On April 2021, NASA's Parker Solar Probe successfully completed the first ever close encounter with the Sun. This groundbreaking achievement has enabled scientists to learn more about our nearest star and the solar activity that impacts life on Earth. But did you know that when the spacecraft reached the Sun, it didn't actually touch it? That's right. It may seem counterintuitive considering how close the probe got, but there's a good reason for this. And today we're going to tell you all about it. Hi, it's me and you're watching this channel. Join with us today as we explore the incredible journey of the Parker Solar Probe and uncover the secrets of what happens when a spacecraft gets too close to the Sun. The Parker Solar Probe launched from Florida aboard a United Launch Alliance Atlas V rocket on August 12, 2018. Its primary mission was to study the Sun from a much closer distance than any previous spacecraft had attempted, enabling scientists to better understand the space weather that can disrupt important technologies on Earth. The probe was designed to withstand the extreme heat and radiation of the Sun's atmosphere, allowing it to venture closer and closer to our star over the course of its mission. After several months of cruising through space, the Parker Solar Probe began its first close approach to the Sun, passing through the so-called critical surface and providing humanity with unprecedented views of our nearest star. But wait a minute, something doesn't add up here. When you look at images of the Sun, you might think that it's just a big ball of burning hot gas. And if that's the case, then shouldn't the spacecraft have been able to touch it? Well, not exactly. You see, unlike solid surfaces like Mars or the Moon, the Sun doesn't have a physical surface that you can land on or touch. Instead, it has an atmosphere that gradually fades into space. But how does a spacecraft get close enough to the Sun to observe it? Well, let's take a closer look. As the Parker Solar Probe approached the Sun, it passed through several layers of the star's atmosphere, each with its own unique features and challenges. The first layer is the photospheric radius, which is the visible surface of the Sun as we see it from Earth. But this is not the closest one can get to the Sun. There are even deeper layers like the convective zone and the radiative zone. These layers are not directly observable, but scientists believe that they exist based on our understanding of how stars work. But what happens when a spacecraft gets really close to the Sun? As the Parker Solar Probe plunged into the Sun's atmosphere, it encountered a phenomenon known as coronal mass ejection. CMEs are massive bursts of plasma and magnetic fields that occur in the Sun's outer atmosphere, the corona. They are one of the most violent and energetic events that can happen in the solar system and can have a significant impact on space weather. One of the key findings of the Parker Solar Probe mission was the discovery that CMEs are not simply thrown outward from the Sun, but are also driven by a shock wave that propagates outward through the solar atmosphere. This finding has helped scientists to better understand the mechanisms that drive CMEs and their impact on Earth. But what would happen if a spacecraft were to get even closer to the Sun? As the Parker Solar Probe continued its descent into the Sun's atmosphere, it passed through another critical point known as the critical surface. This is the boundary between the solar atmosphere and the interplanetary medium, the space between the Sun and other planets. The critical surface is defined as the region where the solar wind changes from being supersonic to subsonic. In other words, it's the point at which the Sun's atmosphere effectively ends and the solar wind begins to flow outward into space. This boundary is named after Swedish scientist Hans S. Hansen, who was awarded the Nobel Prize in Physics in 1970 for his work on magnetohydrodynamics. The concept of the critical surface was first proposed in 1947. He suggested that the solar wind originates in the corona and flows outward due to a magnetic field. This model has since been confirmed by numerous observations from various spacecraft, including the Parker Solar Probe. However, the exact location of the critical surface can vary depending on the strength of the Sun's magnetic field and the speed of the solar wind. During its first close encounter with the Sun, the Parker Solar Probe crossed the critical surface at a distance of about 15.8 solar radii from the center of the star. This is much closer than any previous spacecraft had come to the Sun. At this point, the solar wind has become supersonic and is flowing outward at speeds of up to 180 kilometers per second. The charged particles in the solar wind carry a positive electric charge, which creates a large electric current in the interplanetary medium. This current flows from the Sun to the outer solar system and is one of the largest electric currents known to exist. But what happens when the solar wind reaches Earth? As the solar wind approaches Earth, It interacts with the planet's magnetic field and atmosphere, causing a variety of effects. One of the most important effects of the solar wind on Earth is the auroras. The charged particles in the solar wind are accelerated along Earth's magnetic field lines, causing them to glow and create beautiful displays of light in the sky. But the solar wind can also have more harmful effects on Earth. For example, it can disrupt important technologies, such as the Global Positioning System, GPS. GPS relies on a network of satellites to provide accurate positioning information. However, the solar wind can interfere with these satellites, causing errors in the signals they emit. This can make it difficult or impossible for GPS receivers to function properly, which can be a major problem for things such as air traffic control and military operations. To mitigate the effects of the solar wind on GPS, various measures have been taken, such as developing more robust satellite systems and ground-based backup systems. Additionally, organizations such as the Space Weather Prediction Center, SWPC, provide regular updates and forecasts of space weather conditions to help mitigate the potential impact of solar activity on critical infrastructure. So while the solar wind may be a beautiful and awe-inspiring phenomenon, it is important to take steps to protect our critical technologies from its potential harmful effects. If you want to know what would happen if the Earth suddenly stopped rotating on its axis, then stay tuned for our next video. Just click on the link provided below. Now, despite the challenges posed by the solar wind, the Parker Solar Probe's close encounter with the Sun has provided invaluable insights into the behavior of our nearest star. By studying the data collected by the probe, scientists have been able to learn more about the Sun's atmosphere and the solar activity that can impact life on Earth. The mission is expected to continue returning data until at least 2025, providing us with even more insights into the Sun's behavior. And if you want to learn more about the Parker Solar Probe mission, then you should check out the official website for the most up-to-date information. What do you think? Would you dare to go close to the Sun? Let us know in the comments section below. And don't forget to like and subscribe for more exciting videos. Thank you for watching, and I'll see you next time.